So essentially, the title is Mic by DHI 2014 and also looking ahead. And I'll take the liberty of just stepping back a bit and looking at the general technology trends that we're seeing these years. And the first thing I'll mention are the smart devices, tablets or smartphones. They've really been moving forward, and actually this year it turns out that there's going to be sold more smart tablets than there are going to be sold PCs. So it's definitely a force to be reckoned with. Smart devices, as this thing here, are typically not that heavy CPU-wise. So they're more designed for looking at, say, information or web browsing or very small services. So it's kind of natural to hook that up with cloud computing, essentially having stuff virtualized and making sure that your workhorse is somewhere else than your actual smart device. So that's definitely a thing that we're seeing as well. And last but not least, when we're thinking of tablets, we also need to think about services versus products, where we've been accustomed to everything we do is a product. It's something we install on our machine and work with it there. But we're moving into a situation where there are more services that we want to provide as additions to our products. And one example of that was also mentioned earlier is the use of SaaS, software as a service, which is also one of the options you have available with the Mic by DHI. A couple of other things that are worth mentioning is that even though we see the smart devices moving forward and they're not that powerful, at the same time we're seeing that the PCs that we do have available are becoming more and more powerful in the sense that they'll have multi-processors available. So PCs, typical laptops these days, will have 4 cores as standard, but also considering high-performance computer centers where you have clusters of machines, and these need to be utilized as well for computation. A natural digression is then to talk about operating systems. We've been so accustomed to everything being done in the workplace is Windows-based, but once we look at stuff like this, we're stepping into the world of Linux for our calculations and our heavy-duty work. And last but not least, data is being stored at an, I wouldn't say alarming rate, but at least a very, very quick rate. And we need to have some sort of systems in place to actually being able to filter and to look into this data and utilize that in the best way. So based on that, I'll try and give some insight into how we're trying to sort of answer some of these trends or deal with these trends. And I'll essentially cover 5 things. I'll talk about performance, which is about parallelization. I'll talk about remote execution, about having your simulations carried out not necessarily on your own PC. About data, and that's accessing the relevant data. And then I'll talk about Mic Hydro, which is our next generation water resource product. And last but not least, I'll just give a couple of slides on user involvement and how to influence the process of what actually makes it into a Mic by DHI installation. So, start out with the multiprocess and the performance. When we talk about performance, we very quickly step into the whole area of parallelization, actually utilizing all these cores that we have available on a PC. I took the liberty of taking this snapshot from a standard PC these days, and these little windows up here, they actually indicate the workforce or the workhorse on your machine, whether they're actually working at full throttle. And this here kind of indicates that we have 4 workhorses available, and why aren't they doing the whole thing? Well, to understand that, we need to step into the 3 main approaches to doing parallelization in software. The first one is the shared memory. We have distributed memory and graphical processing unit, which is the latest edition. So we'll start out with the shared memory. The shared memory approach is essentially that you have multiple processors available. They're located on the same PC, but they're all accessing the same memory. So to illustrate that, think of a PC as a box. Well, we usually get a PC in a box anyhow. But within that box, you'll find you have multiple processors, and they're indicated here by these abacus. So they can each do work in parallel, but the issue is they all need to access the same memory. So we end up in some situations where this is the bottleneck. They all need to get to the memory at the same time, so we actually see a drop down. So we've used this technology actually through quite a few of our numerical engines. And what we see is that this graph here indicates the number of processors that we're using, 2, 4, 6. And up here you have the speed up factor. The red curve is the ideal situation. That is, if you put 2 processors on, ideally you should half the speed, or double the speed, and so forth. But as you can see, it actually doesn't go like that. It does increase, but at some point it actually drops off around 6 cores, and that indicates that at that point your memory is the bottleneck. So even though you might be tempted to go out and buy a 16-core machine, you might not get that much out of it running your singular simulation. So another approach is distributed memory. In distributed memory, you're still using multiprocessors, but each of these processors have their own memory space available. So to illustrate that, you should look upon it as being 3 separate processors doing their calculations, and they have their own memory space. So they're no longer competing to get to the memory, and then at regular intervals they interact and exchange information. This is the technology known as MPI. It's a way of distributing your work among various subdomains, and each of these processors, they actually integrate the equations in each of these subdomains. Here's an illustration where we're using 4 subdomains. So within that you've got the green, blue, yellow, and red, and they're distributed to each of these different cores. And at each time step they need to interact by exchanging information across the border. So this technology is actually better in the sense that you won't have the bottleneck in terms of memory, and if you buy the right equipment, you can actually get some very, very impressive speed up results. Here is a similar curve where you've got the red curve is the ideal situation. Notice here that we're actually going up to around 800 processors. So we've launched this on a high performance computer with speedy interaction between the different processors. But the nice thing is we actually see a very nice speed up factor. So here it's worthwhile going out and purchasing a 16-core machine. High performance computing is not sort of a small investment. These things are expensive. But on the other hand, it's been one of the fastest growing IT markets within the last 5 years. I've taken the liberty of picking out this graph here from the top 500 HPCs. And what you'll notice is that it's essentially the green part here is the number of those which are Linux based. So in other words, when we're talking about HPC, we're looking at Linux, which is essentially the main thing when you want to do heavy duty calculations on multi-core machines. So even though HPC is really, really interesting, it also comes at a price tag. So what's sort of the intermediate that we can think about in this case? Well, here is where the GPU comes in, or the graphical processing unit. Graphical processing units are actually something that's been devised through the hardware industry, focusing on the gaming industry. Essentially, the gaming industry needs to do a lot of very simple calculations at the same time, so they can do that on this graphical processing card. And effectively what you've got are hundreds of processing cores on such a card like this. And the nice thing about this card is it only costs in the range of €1,000. The only problem is it's hard to fit into your standard desktop, so you need to have a bigger computer, but again, it's not a major investment compared to an HPC. So we've actually done the parallelization with GPU for our Mike 21 flexible mesh series. And just to give you a background on how that technology works, again, you've got your standard PC with your CPU in it. That accesses some memory, but within that box, you've additionally got your GPU graphical card. So you look upon that as an additional co-processing unit, which has got multiple processors inside. Each of those have their own memory space, and then they interact with the overall memory space like that. So effectively, you've got all your workhorses up here on the graphical processing unit. Unfortunately, this doesn't come like a flick of a switch. You need to do major changes in the code to actually achieve this. But we've done that, and we've had to focus only on the hydrodynamic part for this release, but we got some fairly nice results. We've used the Mediterranean as one of the test beds, and in this case here, it's not possible to scale by essentially just using half the graphics card, or say 25% of the graphics card. It's all or nothing. So the only way to look at the scalability is actually by increasing the mesh. So essentially making the mesh finer and finer and finer, and this way you can see how well it scales. So with that said, this is essentially the curve we're looking at. So down here you have the number of elements, and up here you have the speed up factor compared to using a single CPU of the same setup. So if you're using a fairly coarse grid, you'll get a speed up factor which is around 10. On the other hand, if you go up and use a much more fine grid, then you end up with a speed up factor in the order of 70 compared to a single CPU at a cheap price. So there are 4 curves here. That's because we've got 2 cards in-house, and this is just to illustrate that the younger the card, the better the speed up. GPU cards are designed for gaming. So essentially, originally they were just single precision, which was fine. And when you're doing gaming, it's not that important whether you get all the digits correct. So since then, they've been further refined so you can do double precision on them, and I urge you to do double precision calculations. But we still offer the single precision as well. And the nice thing about the single precision is that you can get really impressive speed up factors way above 100 using this GPU card. But again, I urge you, be cautious because you are losing out on the precision in the calculations. So our preliminary indications are that the performance depended on the GPU hardware. Essentially, the younger the GPU card, the better. We're only basing this on the NVIDIA type of graphical cards, and we also see a good scalability. So essentially, we feel that it's quick and it's cheap, and it's the way to go. So, stepping back on the trends, I just want to touch upon the cloud. Given that we don't all have one of these graphical processing cards in our machine, it would be nice to install this somewhere centrally in the organization, and then essentially access that from the different desktops. And that can be done with our tool, Remote Simulation, where essentially what you do is you set up your simulation locally on your machine, and you fire these off to some workhorses. They crunch away with numbers and come back with the answer, hopefully the one you're looking for. And essentially the nice thing about this is that you don't have to keep your desktop running all the time. You'll fire off the simulation, and you can check in on it at regular intervals. So essentially, when it's ready to run, you fire it off, and the actual simulation is executed on this remote computer. It also works with AutoCal, so you can use this for sort of calibration and optimization. Here's a snapshot of what the console looks like, where you're looking at the various simulations and completion time, and also the state of this. And we're actually also working on making this progress available for your smartphone. So in other words, you can start your simulation before you go home to eat, and then while you're sitting there over dinner, your simulation will tick in and let you know that it's done, or it will tick in and tell you need to do something right now. So essentially it'll be available with release 2014, and it'll be available for corporate subscription type licenses. Okay, data. This I'll briefly touch upon because Mr. Karstad also mentioned this earlier. We have our DHI water data, and essentially it just completes the picture where we've got consultancy, software, customization, training, and now also data fit for use. So effectively, we have some data there that's free, some which you get with service maintenance agreement. You can subscribe to some of it, and finally, you can also buy products directly. So effectively, it's additional value and service for all of you. Here's a snapshot of what the portal looks like. I'd like to mention that we have an online chat as well. So you can go in there and query if there's something you're uncertain about in using the portal. And here's just a couple of examples of the data that's in there. We have some forecasting, here's some topography, and here's precipitation. Next generation, Mike Hydro. Well, mic hydro is essentially taking our mic 11 and our mic basin and combining those into a more encapsulating interface. Those of you who've been working with mic basin and mic 11, you'll find that it's a very nice transition. Essentially, there'll be importers to take you from your existing setups to the new version. It's map-centric, so it's we believe an easy-to-use graphical user interface. We've focused on usability and workflow, and we've actually taken the decision not to have any third-party GIS components required. That does not mean you cannot use your S3 software, but essentially it works independent of that, and you can pull in your data from your S3. It's a mic 0 component, and it's a one setup editor. Here's a snapshot of what it looks like. You've got your cross sections, your map, and also your structures and your tablet view, all in the same editor, along with editing tools as well. For this release, we'll also include part of mic hydro river. It will not be a full-fledged feature set for mic 11, but it will include a subset of your classic mic 11 GUI or GUI features. I urge you to try it out once you get the new release. On mic hydro basin, we're actually including Ecolab in the mic hydro basin. Presently, or previously, we always had hard-coded our water quality in our mic basin. With this, you have the full flexibility of actually working with Ecolab. So you can design your own templates, describe the processes, or pick one of the templates which are already available. So, with that, I'll get to the last point, which is about user involvement, and essentially how to influence the mic by DHI path. The Mic User Council was constituted about 2 years ago, and the primary mission of the User Council is to provide input to DHI in improving the mic products so that they cover the most important modeling needs as seen from the perspective of the members of the Mic User Council. So, and the vision is essentially to see tangible improvement in each new release of the mic products based on the input we get from the Mic User Council. So essentially, it's a feature set up to ensure that you understand we do listen to your needs. And I just want to give you a couple of insights as to what has made it in there, which were originally from the Mic User Council. One of the things is a tool for describing dikes in the Mic 21 topography. So essentially just defining that as an XYZ file and including that, or even having a dike which varies in time to describe a dike breach. We've also included a water balance tool for mic flood, which was also one of the things that was put forward in the Mic User Council. And last but not least, you can input DFS2 files, gridded data, into your mic urban and get that running as well. So, in summary, just a quick recap. Multiprocessors, well, there are a variety of options, and I'd like to mention the Mic 21 FM GPU. Look forward to that with the next release. In terms of cloud computing, remote execution, and the software as a service. Services in general, DHI water data, that's data that fits your needs. Next generation mic, well, that's mic hydro. And last but not least, the listening part of what we do, the Mic User Council, and the user involvement. So with that,